All right, let's dive right in. Today, we're going to tackle a really big question. How do we get computers to actually understand human language? This is the heart of a field called natural language processing, or NLP, and it all starts with turning messy, everyday text into clean, structured data.
I mean, really think about that for a second. How do you take a bunch of articles or maybe thousands of customer reviews and turn that raw, unstructured text into something a machine can actually analyze? That right there is the fundamental challenge we're trying to solve.
So, the whole goal here is to transform that string of characters into clean, organized numbers. You know, for anyone who's worked with relational databases, this should feel kind of familiar. We're basically taking a chaotic pile of documents and turning them into a structured, searchable table that a computer can make sense of.
So, where do we even begin with all this mess? Well, the very first step is what we call preprocessing. It's all about creating some initial order out of the chaos and just getting the text into a format we can actually work with.
We start with something called tokenization. Now, it's a fancy word, but it's a really simple idea. We just break a sentence down into a list of its individual words, or tokens. Think of it like taking a sentence and putting each word on its own separate index card, so we can start sorting and organizing them.
And in practice, this is surprisingly easy to do. With a simple split function in most programming languages, you can read a file and instantly turn a huge block of text into a nice, neat list of all its words. It's a pretty cool first step.
But what if you need to do something more complex? Like, what if you wanted to find every single word that ends in ing, or pull out all the phone numbers from a document? For that kind of pattern matching, we use an incredibly powerful tool called regular expressions.
Okay, so now we have a big list of words. The problem is, a lot of those words are just clutter. Common filler words that don't really add much meaning. So how do we get rid of all that noise so we can find the actual signal in the text? Well, we do this by removing what are called stopwords. These are the most common words in any language. Words like is, about, and. Now, they're essential for grammar when we're talking, but for a computer trying to find the core meaning, they're usually just noise.
And just look at the difference it makes. Once we filter out those common words, we're left with a much cleaner list. This helps us get right to the heart of the sentence, focusing on the words that actually carry the important concepts. Our text is clean now, which is great, but it's still just a list of words. And here's the thing, computers don't speak English, they speak math. So how do we finally make that leap and convert these words into the numbers a machine can work with?
This next step is absolutely crucial. It's called feature engineering. And for what we're doing, it just means converting our clean text into a useful numerical form, creating features that a machine learning algorithm can actually understand and process. The most straightforward way to do this is a method called count vectorization. And it is exactly what it sounds like. For every single document, we just count how many times each unique word shows up. Simple as that.
What you end up with is this really simple matrix. Each row represents a document, and each column represents a unique word from our entire collection. The cells, they just hold the word counts. It's a dead simple, but incredibly powerful way to finally give our text some structure.
But this brings up a really important question, right? Does a word's frequency alone tell us how important it is? Just because the word learning shows up 5 times, is it automatically more significant than some rare, super specific term that only appears once? Yeah, not always. And that's exactly why we have a more advanced technique called TF-IDF. This helps us figure out which words are truly important to a specific document by weighing them, not just by counting them. So TF-IDF has 2 parts. The first part is term frequency, or TF. That's the easy part. It just measures how often a word shows up in one single document compared to the total word count in that same document. But the second part, inverse document frequency, or IDF, this is where the magic happens. This step looks across all of our documents. It gives a higher weight or a higher score to words that are rare overall, and it pushes down the score of very common words. So a word like algorithm might be frequent in one article, but if it's rare everywhere else, IDF flags it as important. And the final TF-IDF score is just a result of multiplying those 2 numbers together. What this means is that a word gets the highest score when it's frequent in one document, but pretty rare everywhere else. That score is a much, much better indicator of a word's true importance. So after all that, why did we go through all this trouble? We've tokenized, we've cleaned, we've converted our text into these carefully calculated numbers. What's the big payoff here?
Because now that our text is in this structured, numerical format, we can finally unleash the power of machine learning. We can automatically classify documents, analyze the sentiment of customer reviews, discover hidden topics across thousands of articles. We can even build way smarter search engines.
This entire process, turning human language into numbers, is the fundamental building block for so much of the AI technology that we use every single day. And it really leaves us with one exciting question to think about. Now that we can translate our words into the language of math, what can we truly build next?
If you found this explainer helpful for understanding that bridge between our language and machine logic, please hit that like button, share it, and subscribe for more deep dives. Thanks so much for watching.